Hello and welcome. Our topic for the day is refine your search systems, migrate to Elasticsearch. My name is Ishan Tazib and I am the practice head for HCL Commerce at Royal Cyber. Accompanying me for the day is Vivek Rana, who's a senior technical lead for HCL Commerce at Royal Cyber. We'll be covering the following topics today as a part of this webinar. What is Elasticsearch? Why migrate to Elasticsearch? Empowering business and tax stacks with Elasticsearch. Some success stories, Elasticsearch architecture, components and features, some demo use cases, and finally Q&A. We'll start with a brief overview of the company. So Royal Cyber is an IT consulting and digital transformation company specializing in services, solutions, and software. We've been around for more than 20 years now with 1,500 plus employees across the globe and 250 plus certified consultants. With mothership in Chicago, Illinois, we have offices now all across the globe. So what's Elasticsearch? Elasticsearch is an open source distributed free search engine designed in Apache Lucene. It is an enterprise level search engine popular for its high speed, flexibility, scalability, REST APIs, and contains a bunch of free data ingestion, storage, enrichment, analysis, and visualizations tools. Elasticsearch searches and indexes information in various formats, including text, numbers, structured, unstructured, and geospatials. It supports the following languages: PHP, Perl, Go, Java, JavaScript, Python, Ruby, and .NET. And it helps user to get quick search responses by searching the index rather than text directly. In simple words, it is same as searching for a keyword by checking the index instead of searching each word of the book. It is possible to scale Elasticsearch to multiple servers storing petabytes of data. This capability of Elasticsearch allows it to be used in multiple use cases, which are listed below. Security analytics, analyze access logs to track what's happening across the systems in real time. Business analytics helps organization with multiple data sources to perform analytics. Website search, website with voluminous contents use Elasticsearch for precise results. Application search, applications depend on search platform to retrieve and report data. Logging and log analytics utilized to ingest and analyze log data in real time, providing essential details on log metrics to act. Infrastructure metrics and container monitoring, analyze metrics and collect data for performance parameters. Enterprise search facilitate extensive searching of information across different platforms. So why migrate to Elasticsearch? And we'll discuss some of the key features that Elasticsearch offers. First one is the multiple search option. Elasticsearch uses various search methods, including full text search, instant search, fuzzy search, faceted search, auto completion, customized stemming, and splitting text into words. Fuzzy search gives search results based on entered query. Even if you entered misspelled queries, auto completion helps search by predicting query based on the user's input. Distributed natures, the file in Elasticsearch are divided into multiple containers known as shards, which are duplicated to have replicas that can be used in time of hardware breakdown. When a new file is added, Elasticsearch performs routing and rebalancing tasks automatically. It's really quick. Elasticsearch is high speed and provides the best result for full text search. The time taken to index a document and shadow it in the search result is very low, usually 1 second. Also, it caches the structure queries for result sets and runs them only once. After that, it retrieves search results from the cache for further requests that have a cache filter. Therefore, it can be used for short-lived use cases, which include security analytics and infrastructure monitoring. Easy data ingestion, visualization, and reporting. Elasticsearch can easily integrate with Logstash and Beats to simplify data processing ahead of indexing into Elasticsearch. Logstash is a server-side data processing tool that collects data from multiple sources, processes, and transfer it to Elasticsearch. Beats is a free platform for single-purpose data shipping agents to transfer data for system to Logstash or Elasticsearch. In addition, Kibana offers real-time visualization of Elasticsearch data line graphs, pie charts, and histograms. Scalability. The distributed approach makes it easy to scale Elasticsearch horizontally by adding resources and maintaining loading balance between cluster nodes. It has robust pre-built features that facilitate efficient data storage and search. Document oriented, all the entities are stored as structured JSON documents with index fields by default with superior performance. The JSON powered DSL enables developers to create intricate queries to retrieve accurate search results. Empowering business and tax stack with Elasticsearch. Elasticsearch is a powerful open source search analytics engine that can be used to empower businesses and their tax stacks in several ways. One of the main benefits of Elasticsearch is its ability to handle large amounts of data and provide fast search results. This makes it well suited for use cases such as e-commerce search, log analysis, and business intelligence. For example, an e-commerce company can use Elasticsearch to quickly search through their product catalog and provide relevant search results to the customers. Another key benefit of Elasticsearch is its scalability. It can be used to handle large amount of data and can be easily scaled up or down as needed. This makes it a great choice for business that need to handle a lot of data or expect to grow in the future. Elasticsearch also has a wide range of powerful features, such as full text search, spatial search, and analytics. These features can be used to gain insights from the data and make better decisions, business decisions better. For example, a company can use Elasticsearch to analyze customer data and gain insights into customer behavior and preferences. Additionally, Elasticsearch has a large scale active community which provides many plugins and integration that can be used to extend its functionality. This allows business to easily integrate Elasticsearch with other tools and systems they use. So overall, Elasticsearch is a powerful tool that can be used to empower business and their tech stacks in a number of ways. Whether it's used for e-commerce search, log analysis, or business intelligence, Elasticsearch can help business handle large amounts of data and gain insights from it, leading to better decision making and improved business outcomes. A few success stories of Elasticsearch deployment with e-commerce. There are many successful stories for e-commerce websites that have implemented Elasticsearch for their search functionalities. Here are a few examples. So Zalando, one of Europe's largest online fashion retailers, uses Elasticsearch to power its search functionality. The company reported a 30% increase in conversion rates and a 40% increase in search relevancy after implementing Elasticsearch. Birchbox, an online subscription service for beauty products, also uses Elasticsearch to improve search functionality on their website. The company reported a 30% increase in search generated revenue after implementing Elasticsearch. Wayfair, an online furniture retailer use case, uses Elasticsearch to power its search functionality. The company reported a 15% increase in conversion rates and a 50% reduction in search latency after implementing Elasticsearch. Etsy, an e-commerce website focused on handmade or vintage items and supplies, uses Elasticsearch to provide power its search functionality. The company reported a 10% increase in conversion rates and a 20% increase in search relevance after implementing Elasticsearch. Ticketmaster, an online ticket sales platform, uses Elasticsearch to power its search functionality. The company reported a 20% increase in conversion rates and a 50% reduction in search latency after implementing Elasticsearch. So these are a few examples of many e-commerce websites that you'll see have improved after implementing Elasticsearch and reduced the search latency by some exceptional margins. For the remaining of my slides, I would like to onboard Vivek Rana, who will be helping me with completing this webinar, and he'll be taking care of the technical side of implementations.
Hello everyone, I'm Vivek Rana, working as a senior technical lead with Royal Cyber. Let's begin with a basic overview of Solr search solution provided with HCL Commerce. HCL Commerce Search uses Apache Lucene as the basis of its search framework, making integration with third-party applications an easier process. Lucene powers the Apache Solr search engine as well as the Elasticsearch engine. Solr runs as a traditional monolithic application within a dedicated search container. This architecture provides both stability and scalability. The indexing pipeline is more open, flexible, and scalable, and is tightly integrated with the data service. Using the underlying data flow technology and architecture, you can easily customize the pipelines. This open standards approach considerably eases the process of integrating search with existing and third-party applications. HCL Commerce Search uses a multi-channel container-based system for search and merchandising. At the front end, HCL Commerce Search interacts with users and other components of the store environment by using HTTP REST requests. On the server, it merges the speed of relational databases with the flexibility of unstructured XML. As the queries come in, they are transformed into XML documents whose content is compared against a detailed index by Apache Solr engine to return the search results. Let's move on to the overview of Elasticsearch. Elasticsearch solution is one component of a unified data environment. This environment is designed as a generic data management system that can be used by other commerce subsystems as well. HCL Commerce Search with Elasticsearch consists of several data microservices, each of which runs in its own container, and each microservice has its own responsibility. The environment includes several major components, including the gateway, data services, and the Zookeeper configuration management system. Along with the ingest service that brings in the data, the new query service provides natural language processing, color recognition, and more. HCL Commerce Search service introduced in version 9.1 provides you with improved scaling, simpler administration, and enhanced security. The Docker container stack that runs microservices is hosted on CentOS and uses the Spring Boot framework. These microservices retain backwards compatibility with your commerce transaction server, storefront, and XE customizations. For customers who need backwards compatibility, the previous Apache Solr based search solution is still available. The search API remains the same regardless of whether you're using Solr or Elasticsearch, which means that most customers will be able to switch to Elasticsearch with no impact on the storefront. Let's have a look at the features of Elasticsearch based solution. With Elasticsearch based solution, there is no storefront impact and it contains an extensible ingest service that leverages Apache NiFi. It also uses natural language or NLP as and has enhanced query service and reuses existing query framework. It uses Zookeeper for dynamic configuration and is Kubernetes ready. So what does all this mean? Elasticsearch gives you a flexible indexing pipeline with expansive ETL capabilities, language-aware fields, part-of-speech tagging, name entity extraction, and custom dictionaries, along with near real-time updates and Elasticsearch index aliasing. It is also intelligent query service that contains NLP with part-of-speech tagging where nouns map to product name, brand, and adjectives map to attributes. It also does matchmaking for color dimension and range search along with measurement conversion. Following are the features of Elasticsearch solution. Natural language processing or NLP with standard core NLP. The NLP system improves search relevance with models provided for English, Spanish, French, German, Arabic, and Chinese. Most core NLP language models are capable of performing tokenization, lemmatization, part of speech tagging, and name entity recognition, sentence splitting, and sentiment analysis. They can perform grammatical analysis with constituency, dependency parsing, and co-reference. An additional NLP processor has been added to provide additional matchmaking capabilities such as finding similar colors or measurements and automatic measurement conversion. Fully integrated with Elasticsearch as a default core search technology. It has enhanced multilingual support with over 30 built-in language-specific analyzers for text analysis, such as tokenization, stemming, stop words. Dynamic index shards allow more nodes to be dynamically added, and rebalance data automatically across the cluster with zero downtime. Hot swapping for newly built indexes using index aliases. Re-indexing has minimal impact on your live cluster. Fast incremental snapshots, which allow you to backup at frequent intervals. Data ingestion through indexing pipelines in Apache NiFi. HCL Commerce Search Service fully supports multi-tier marketing and features near real-time updates. It is a Kubernetes-ready deployment interface. It has seamless service upgrade and version control. Seamless service container upgrade allows new features and bug fixes to be delivered continuously through recurring service packs. This slide shows the basic architecture of an Elasticsearch-based solution. Let's discuss in brief about the components of the Elasticsearch. The first component is ingest service. This microservices manages the write operation. It performs essential extraction, transformation, and loading or ETL operations on business data that make them available to the search index. The business logic behind indexing lifecycle, which previously resided in transaction server, is now managed here. The ingest service uses an indexing pipeline that runs on Apache NiFi. It uses customizable connectors that allow you to completely control how your data is indexed without requiring you to write a single line of code. Each connector is a processor that does some particular manipulation to the data as it is passed along the pipeline. By stringing different connectors together, you enable different kinds of indexing pipeline logic. There is one NiFi cluster per environment shared between authoring and live. NiFi cluster consists of NiFi nodes. To extend default ingest data flow, you either need to create a new connector or modify an existing connector. Second is the query service. The query service builds the search expression and then hands the expression to Elasticsearch. It also takes the query results and translates them back to the form that can be understood by the storefront. The storefront does not need to know that the response was generated by Elasticsearch rather than Solr. Apache NiFi. NiFi is an indexing pipeline used by ingest service. It uses connectors to bring in raw data and convert it into a form that can be used by Elasticsearch. You can use the default NiFi connectors for known data types or define your own so that NiFi can bring in custom data types. NiFi runs in its own container and is fully extensible. Elasticsearch. The query search service and the profile determine the best way to handle the search query. Elasticsearch uses its high performance engine to run the search and then response is filtered back through the search profile before being handled back to the storefront. Using the search profile to filter the response means that the storefront does not need to know that it's interfacing with Elasticsearch instead of Solr. The index can be built as a separate persistent volume. Elasticsearch's distributed index paradigm allows it to be built and updated on a continuous basis and remains intact the even if the other Docker containers are taken down. The following services run internal to the data platform, meaning that the APIs are not exposed directly to the outside world. Access to them is through Nginx Gateway. The first one is Redis. Redis is used to message bus for distributing change events as well as cache invalidation events. Zookeeper. Zookeeper is used to store your default and custom configurations, connector descriptors, along with custom properties and extensions. It starts with your search profile and ingest profile already present. When the microservice containers start, they boot into a preset stable configuration. At runtime, each microservice pulls Zookeeper for any custom configurations it may also have stored. It will automatically override default behaviors such as query replies and the load custom applications such as new NiFi connectors. Now let's discuss why it's important to have a good migration strategy in place. Migrating from Solr to Elasticsearch can be a complex process, and having a well-planned migration strategy is crucial to ensure smooth transition. A migration strategy should take into account the current Solr environment, the desired Elasticsearch environment, and the data being migrated. This can include things like identifying which Solr cores or collections need to be migrated, how to handle differences in data mapping and analysis between the two systems, and how to handle any custom plugins or configurations. A good migration strategy should also include testing and validation steps to ensure that the data has been successfully migrated and the new Elasticsearch environment is properly configured and optimized for performance. Overall, a migration strategy is important to minimize disruptions to your search capabilities and to ensure that your data is properly migrated, indexed, and searchable. Some key considerations for a migration strategy may include data mapping. Determine how to map the data fields in your Solr index to the appropriate fields in Elasticsearch. Re-indexing. Decide whether to re-index all data or only the recent data. Deployment. Planning for deployment of the new Elasticsearch cluster, including testing and monitoring. Testing. Testing the migrating data to ensure that it is accurate and complete. Performance tuning. Tuning the performance of Elasticsearch cluster to ensure that it can handle the workload and provide fast response times. Rollback plan. Have a plan in place in case the migration is unsuccessful. Monitoring. Monitor the migration process to ensure it is progressing as expected and to quickly identify and resolve any issues that arise. Retraining models. Retraining machine learning models that use search data as the data format may be different in Elasticsearch. It's also important to consider the cutover plan, the management of data during the migration and rollback plan in any case of the issues. Overall, by having a well thought out migration strategy in place, you can minimize the risk of data loss or downtime and ensure a smooth transition from Solr to Elasticsearch and minimize any disruption to the users. So how you should plan your migration. To be very precise, moving to the new Elasticsearch Power solution is more adoption than migration. It's a completely different solution and not a new version of Solr. New things in Elasticsearch may not be parallel in Solr. Some of the customizations in Solr might be unnecessary in Elasticsearch solution. HCL's new search solution is built on Elasticsearch, which has been in use for some time and running some very large sites. HCL Commerce has wrapped its capabilities around Elasticsearch to make it more accessible. The Lucene component has carried over to this solution also, but there are changes as well. There has been a considerable change in the programming model and the development lifecycle. It's important that you understand what you have. There are new features. You should do a gap analysis, and this is a good time to recapture the business requirements. If you have previously customized indexing configuration or templates or the search runtime, then you may need to migrate your customizations. During assessment, there are new capabilities that you should examine and understand in order to do gap analysis and improvements. NLP can understand parts of speech and make searches more focused and relevant. Filters allow statements like between size 10 and 12 to be meaningful. Matchmakers can be configured to return colors near ivory on a color wheel rather than only products with literal attribute of ivory. The new indexing process is very flexible and customizable and allows NRT updates so that changes made can be viewed very quickly. Some processing has been moved into the index to make a more efficient lifecycle. The data and index lifecycle has been improved, getting data into index from multiple sources, ingesting data from multiple data sources, FTP, websites, etc., unstructured and structured data. There is more flexibility and data transformation capabilities to prepare for search index build. The new runtime model moves processing to the index, so some previous configurations for pre and post processing will no longer be needed. The previous Solr solution flows needs to be carefully assessed and in some situations changes are required. In other situations configurations remain valid. The whole indexing process will need to be created using the ingest service and the connectors and pipelines that it is composed of. The days of severely restricted update windows are over. This solution supports publish, at will 24 hours. A full index may take a bit longer, but the new paradigm mitigates that because near real-time updates are more capable and reliable than data indexes have been. There has been a lot of work done on pipeline indexing, architectural flexibility for multiple sites and multiple indexes. Continuous content updates is the goal. Using flow programming model and the visual UI supports rapid ingestion, there is a learning curve, but when you learn it, it has tremendous capabilities. All the processes available to fetch data, more flexible and lightweight dev tools available as well. How should you migrate your customizations? You have several options in migrating from Solr Search platform to the version 9.1 Elasticsearch solution. Following are the general guideline to help you migrate your Solr Search based solution to Elasticsearch based solution. Define all index field definitions in Solr schema.xml in the data specification of all object types. A NiFi ingest service connector element. Index field definitions that were previously located in Solr schema XML files are now defined in data specification for each object. That is the part of the NiFi ingest service connector. Define ETL processes in the NiFi ingest service connector. The ingest service manages ingestion, processes data from varied sources, and transforms data in memory in the Apache NiFi cluster. The approach to pre-processing data for index has changed significantly with the new HCL Commerce version 9.1 architecture. Pre-process configuration is no longer defined in XML files, and there are no temporary database tables needed for flattening of the index data. The new ingest service handles the extraction or ingestion and has the flexibility to process data from many different sources and to transform the data in memory in a high performance Apache NiFi cluster. The ETL processes are defined in NiFi ingest service connector. Update the required fields in existing index document with help of incremental index updates. Extension indexes are no longer necessary. This solution was introduced for use in Solr-based search solution to avoid rebuilding the entire base catalog entry index document when only certain frequently changed fields such as inventory and price are updated. Now with the ability of incremental index update, it is possible to update only the desired fields in any existing index document. Limitations of extension indexes, including the inability to perform sorting, faceting, grouping are now lifted with HCL Commerce 9.1 with the Elasticsearch based search solution. This is due to the fact that all fields are now in the same product index. Create a single ingest connector for every document source. This simplifies customizing extensions that ingest data and load it to the search component indexing. A single ingest connector needs to be created for each source of documents. This process allows you to more easily customize the extensions that will consume the data and load it into indexes of search component. Create a custom connector pipeline to load data. The site crawler collects page URLs, however, it doesn't load data into search box automatically. With HCL Commerce 9.1, the site crawler can continue to be used to gather the URLs of the pages, but it will not automatically load the data into search index. However, a custom connector and pipeline can be created to load the data. Zookeeper stores custom configurations and overrides default behaviors, for example, query responses. In HCL Commerce 9.1, Zookeeper is used to store custom configurations. At runtime, each microservice pulls Zookeeper for any custom configurations to automatically override default behaviors such as query responses. For ingest service, Zookeeper stores connector descriptors that are used for loading new custom NiFi connectors. Assess Solr-based search profiles, defined expression providers, and custom pre and post processors in the profiles. Existing Solr search profiles should be assessed along with defined expression providers and any custom query pre and post processors in the profiles. The introduction of NLP in the new HCL Commerce version 9.1 Elasticsearch based solution may provide an opportunity to remove runtime customizations that are defined in your Solr based search profiles. Evaluate custom providers associated with search relevancy and ranking concerning natural language processing. Custom expressions providers related to search relevancy and ranking should be assessed and evaluated considering the addition of natural language processing. Assess custom preprocessors related to search relevancy and ranking. The Elasticsearch-based solution provides significant enhancements to search matching and ranking with the introduction of natural language processing that may provide an opportunity to remove runtime customizations related search relevancy. Custom preprocessors related to search relevancy and ranking should be assessed and evaluated considering the addition of NLP. Assess custom query post processors to determine whether the customization could be recreated. Custom query post processors should be assessed to determine whether the customization could be recreated as a NiFi ingest service connector and used to structure the static Elasticsearch index. Custom post processors that cannot be moved to index time will need to be recreated as the Elasticsearch response is in a different format from the Solr search response. Storefronts should be evaluated for compatibility and updated to utilize the HCL Commerce V1 REST API. Client microservices to expose custom data should be evaluated for caching and invalidation requirements. Custom Kafka events should be migrated to Redis. Now we are going to showcase some examples highlighting the key differences between Solr and Elasticsearch based solutions. HCL Commerce Search Service uses an extended version of Stanford Core NLP language processor. In addition to part of speech tagging and other Stanford NLP features, HCL Commerce Search provides a range of filters, units of measures, and colors. It also supports stemming. Two main examples that we are showcasing today are ranges and units of measure, and the second one is matchmakers. Let's see few examples. Ranges and units of measure. Shoppers often want to find products with particular price ranges. If you search in an e-commerce store for shoes over 200, for example, the results will differ depending on whether you are using Solr Search or the new Elasticsearch system. Let's see how the results look like in Solr search engine. We can see it returns 48 results and the results are not relevant with the search query. As we can see that the results are also containing shoes which are priced less than $200. If you do the same search using the Elasticsearch, the results will be different. Let us see how it differs. It returns only two results, and the results are relevant with the search query. The NLP processor is even more flexible than this. If you choose a range, for example, using the search string, show me shoes from 50 to 60, the system returns an appropriate results. Let's see. So we can see it returns appropriate results, that is the shoes which have a price range from 50 to 60. Constructors such as more than or less than, under, over, or from are easily interpreted by the processor. The next property that we are going to discuss is matchmaker. Let's have a look at the matchmakers. There are two types of matchmakers available at present, color matchmaker and the measurement or the dimension matchmaker. A color matchmaker lets you search within the color families. For example, if you search for color ivory using Solr Search, it returns only two items. Let's see. Both are returned because they explicitly are defined in a facet of the catalog as being ivory in color. In other words, searching on colors works only when the colors are explicitly defined and only for exact matches. When doing the same search using Elasticsearch, different results are returned. Let us see. This search returned 51 items, which are all share the characteristics of being within the white color family. What makes this possible is a set of over 100 predefined colors, each of which is given a position in the numeric color space. The second set of matchmakers that is available is the measurement matchmaker. Measurements are useful for customers who are looking for a product with a particular characteristics. For example, suppose that a customer is looking for a laptop with long battery life. If you use the Solr search engine to search for a 3-hour battery life laptop, it will return all the laptops in the catalog. So we can see it returns all the laptops which are available in the catalog. On the other hand, if we do the same search using the Elasticsearch engine, the results will be different. Let's see. So when we use Elasticsearch system, exactly one laptop is returned, the one in the catalog that is defined as having 3-hour battery life. Unit of measurement conversion is built into the system. If the customer were to use minutes instead of hours, the search for 180-minute battery life laptop, the same catalog item would be returned, even though the laptop's battery life is not defined in minutes in the catalog. The query service automatically converts the unit of measurement in the query string into their equivalents and search the catalog for any instances that match under the conversion. Let's see. So here we can see it returns the same results even when we are using a different unit of measurement. Now, why you should consider Royal Cyber for your Elasticsearch migration. If you're looking to upgrade your search systems to Elasticsearch, reaching out to Royal Cyber certified HCL Commerce experts is a wise decision. Our experts offer the best consultation to help you understand the process and perform a migration that is smooth, efficient, non-disruptive to your business operations. By deploying Elasticsearch, we can help you scale your business by providing improved dynamic searches and analytic functionalities. Elasticsearch is a powerful search engine that can provide many benefits such as accurate search results, real-time analytics, and much more. Reaching out to us will give you the opportunity to learn more about how we can help you take advantage of Elasticsearch capabilities and how it can help your business. Our experts will help you understand the process and guide you through migration so that you can focus on running your business while we take care of the technical aspects. Don't hesitate to reach out to us and let you help us improve your search systems and scale your business. We are now open for questions and answers. Thank you.